I will say, the next thing I say may be mind-blowing to you.
Okay.
Okay? The tide doesn't actually come in and out. What? What happens is, there is a bulge of water, two of them, on opposite sides of the Earth, caused by the sun and the moon, and Earth turns inside that bulge. Mm-hmm. So when we say the water rises and falls, tidally, what's happening is we are rotating into the bulge and then out of the bulge.
So the bulge is already there.
It's already there.
And all we kind of do is pass through the bulge.
Pass through, and the water gets high and it gets low. So we're stuck with language from our own perspective rather than language of what's actually happening. It's simpler that way to say the water goes in and out. It's simpler to say the sun set rather than Earth rotated such that our angle of view on the stationary sun fell below our local horizon.
Right. Yeah, sunset is far more poetic.
Yeah, you go to the sunset tables, to look this up.
Yeah, because you can't say to a girl, hey, how'd you like to go and watch the angular momentum of the Earth cause the sun to disappear behind a horizon?
Hello, where'd you go? Let's look at just the Earth and the moon for the moment.
Okay. Which
There's
many people think the moon is what causes it.
No, the moon is 2/3 of the tides.
Okay.
The sun is another, it's 2/3, 3/4, depends on the distance. The sun has its own tides on the Earth.
Oh, snap.
Wait, in fact, the tides that the moon raises on Earth are the same no matter the phase.
Okay. No matter the phase of the moon, which there are some people believe that when you have a full moon, what you have is a higher tide because you have a fuller moon.
You do have a higher tide.
Oh, snap.
But the tide that the moon raises on the Earth is basically the same no matter its phase.
No matter its phase.
What happens at full moon is that the sun's tides add to the moon's tides precisely.
Oh, snap. We talking about a tide assist from the sun?
Tide assist.
Oh!
A tide assist. And so that's why...
And that coincides with the full moon.
Coincides with the full moon. Because the full moon, you got the moon here, Earth, and the sun. Everybody lines up.
That's what it is.
In fact, we have a word for that.
Go ahead.
That has the most number of letters when scripted, a dip below the line.
Okay.
I know that's a weird record to hold.
Right.
The word is syzygy. So syzygy is when 3 or more objects come into alignment cosmically.
Right.
So you have the moon, the Earth. The moon will have the same tide it would at any time, but now it lines up with the sun.
Right.
They add together, you get the highest tides at full moon and new moon. So now I ask you, when would you get the lowest tides?
When the sun is not lined up.
Okay. Okay, let me quantify that. So when the sun is at 90 degrees, the sun is pulling this way, and the moon is pulling that way, and the two waves basically cancel.
Exactly.
They try to cancel one another, so you have the lowest tide. It's called the neap tide.
The neap?
Neap.
Neap tide.
Neap tide.
See, look at this. It's not the moon. It was the sun all
the time. It was the sun all the time.
I see, and you think because, see...
Wait, so when people say, I feel the extra tidal forces from the moon when it's full, it's just bullshit.
Oh.
So just want to clear that up.
Okay.
So I haven't explained tides yet. Let me take 2 minutes to explain that.
Holy crap. That was just about the moon and the sun and the fact that the bulge. So that's what we have right now.
So watch what happens.
Go for it.
So let's just look at Earth and the moon for the moment. The side of the Earth that's closest to the moon feels a stronger gravitational pull of the moon than the side of the Earth that's farthest away. Okay?
Right.
The closer you are to the source of gravity, the stronger is that force.
Right.
Is that force. So that's true for everything.
Right.
No matter
so the
what.
moon is always exerting a gravitational pull on the Earth.
On the Earth, yes. And there's a difference in the gravitational pull from one side to the other.
Okay.
Because if there's a difference, it means it's pulling this harder than that.
Right.
If you do that, you end up stretching.
Okay.
So the water stretches along the line that the moon's tidal forces are pulling.
Gotcha.
Okay, it's a stretching force.
Right.
All right? And by the way,
we're gonna call that Earth Yoga. so yes. And now, downward dog.
So it does that for anything. Water happens to be more responsive to this force because it's liquid, but it also raises tides on the solid Earth. Oh. But you don't see that happening.
You're not gonna see that.
You don't know, and it's small, much smaller, and so, but it does it basically for everything. And so that's how you get a tides. That's how you get the tides.
Wow.
And so that bulge is always there, but the sun is messing with it.
Right.
Okay?
Exactly.
So as the moon orbits the Earth, and the tidal bulge sort of
is
moving with the moon.
Right.
And the sun is like
exerting its forces simultaneously.
Simultaneously, and it either lines up or it doesn't.
Wow.
Okay. How much brain you got left to get?
I don't know, man. We are about this.
Okay, so now watch.
We were only working with this to begin with. Now we down to about this.
Okay, so watch what happens.
Go ahead.
So it turns out we are rotating faster than the time it takes the moon to go around the Earth. Okay? So a day is shorter than a month. Okay? All right. So we are actually, if you, the viewer, are the moon, and you're trying to raise this bulge, okay? I am dragging the bulge ahead of you because I'm rotating faster.
That's right.
Okay, so the bulge is not actually exactly aligned.
No, it's over here.
It's like that way,
and then
at that angle.
And you're pulling.
So now watch. So watch. So it's because I'm rotating. So now watch. So the moon is actually tugging on that bulge, trying to line it back up.
Right.
And it does that against the wishes of our rotation.
Right.
So the tidal bulge, because of the moon, is slowing down the rotation of the Earth.
So are you telling me that...
That's why we have leap seconds.
There you go.
So the tides are not only responsible for what we perceive as water going in and out, it's responsible for the slowing down of the rotation of the Earth. And the Earth has been slowing down ever since the moon has existed. Okay, and we know this because there are mollusks that have certain features in their physical body that attract to the phases of the moon. Okay?
Really?
Yes. Okay. So attract to when they're stuck on the ground versus when they're in, the tide comes and gets them. Okay. There's a record of the cyclings of the moon, of the tides. Now watch. We also have other evidence for how many of those cyclings occur in a calendar year.
Right.
And back then, there were more of them. Okay.
So the fact
which meant that Earth rotated faster back then. Yes. So the moon has been slowing us down ever since.
Or the Earth is just getting really tired.
And then there are people who say, if the moon affects the water, and the water's made of water, and we're mostly water, what doesn't the moon affect us? Because we're 80 to 70% water. It's a natural thing to think about.
Which is when people say that, people act weird during a full moon.
Yeah, even though the moon's tides are not stronger. Okay.
It's really the sun.
It's really the sun.
See? Full circle, baby.
Right.
Just like Earth.
But you want to explain lunatics. They're really sunatics.
They're sunatics. It's like solatics.
Solatics, that's way better.
That's what they would be.
Yeah, you're a solatic.
You're a solatic.
So here's the thing. The moon creates a tidal force across your skull. Okay?
I did not know that.
Yes. Across anything.
Right.
This side of your head is closer to the moon than this side of your head.
Okay.
But we can calculate what that difference in gravity is across your head.
Really?
It's not very much.
Damn, man, why you gotta do that to me?
It's not. Because you got a little head. So you can calculate how much that is, and then you can compare it to other things that are operating on your head. Like you go to sleep, there's a pillow sitting right here.
Right.
The weight of the pillow to distort your skull is about 1 trillion times stronger than the tidal force of the moon's gravity across your skull. But no one creates whole mystical predictions about
what your pillow's going to do.
What brand of pillow you slept with last night. So there are very strong ways you can demonstrate that really there's no effect on people, other than the effect you think it's supposed to have.
Right.
You come out of the bar at 2 a.m, full moon is up. Oh, it's a full moon.
Right. I'm going crazy. It has nothing to do with all that Jack Daniels in there.
Yeah.
That too.